Hello, ladies and gentlemen. We are back. We're going to talk about capacitors. We looked at phasor notation for inductors earlier, and now we're going to look at capacitors. So here's our circuit. Current is given by that, capacitance times dV dt. And using our exponential notation, we get this result. V would be the source. And factoring out the e to the j omega t's finally reduces to this. J I is equal to j omega c times v, but so that expresses that I leads the voltage. Remember previously that the voltage led the current in inductors? In this case, the current leads the voltage. So here's the current here, and it's just think of it like when you add the j omega t thing, it's like these vectors are just rotating around, pointing in a circle. So voltage lags the current, or current leads the voltage. Current leads, voltage lags, just what I said. Okay, so we're going to use the example of 100 microfarads capacitor, and if I can find my mouse, there it is. You guys can see that little yellow highlight mouse. I can't. Anyway, programs, what can you say? So remembering this is in microfarads, by the way. So excuse me, this is not. We have 100 microfarads. This is an amplitude in voltage. Watch out. I nearly tripped myself up there. So we can express it in the phasor notation. The current can be expressed like we did before. J equals e to the j pi over 2, or j 90 degrees. So we can express the current like this. V is remembering the substitution. And multiply all the things together. Add angles. Angles add. The amplitudes multiply. Ain't too tough, actually. Ain't too tough. Once you get used to it. Once you get used to it. So now we have an example where we have this information. We know the current across an inductor. There we go. In the phasor notation. Frequency 60 hertz, so omega would be 2 pi f. Yeah, 120 pi radians per second. They drop units too, so we just have to keep our units in the back of our head. Just remember that the units are still there. They don't go away. And what those units are, like the previous example, it was microfarads. It wasn't farads, so just be careful. So now the equation is this. J is in the phasor notation is this. The current in the phasor notation was given up here as this, and then you multiply the leading factors, the amplitudes. And here's j omega right there, and then L right there. So we can run the calculations. 90 minus 30 is 60 degrees. V is at phase angle of 60. Current is at a phase angle of negative 30 degrees. So there we go. An example with capacitors. Similar type of problem. Same frequency, by the way, you'll notice. They didn't change the frequency. We have a voltage source. We have to invert this equation to get voltage in terms of current. So voltage lags the current in this case. 1 over J, well, here's the division right there. There's dividing by J. This is the leading factors. 3.6 divided by 120 pi times 150 times 10 to the negative 6. 150 microfarads, or there's the 10 to the negative 6. There's the micro into the 10 to the negative 6. And crunching numbers, negative 145 minus 90. When you're dividing, it's a negative. When you're adding, you're adding them together. So it's 90 degrees plus a negative 30. When you're dividing, it's negative 145 minus 90. A couple examples there. And generally speaking, we want to put this in terms of, we want phase angles between negative 180 and positive 180. So we add 360 to this. And that would give us 125. If I've done my math in my head correctly. Okay, I'm going to save this for the next video, and I'll see you guys later.